Any questions on the homework assignments before we get started?
I've got some of the homework now already. I've got like 4 points tomorrow. Mr. McClendon, you going to Kevin Gates' concert?
I'm not.
You said 4.4 was for credit, right?
Bonus.
Oh, and then I have a matrix homework.
Did someone make that for you?
They did.
Who did it?
Bryce or Vince's dad. Vince's dad did.
Vince's dad.
All right. 4-6. So the first thing we're looking at is this table here. The table shows several polynomial functions of degree n. Probably both.
I said, I know you're figuring it up, but I don't know how to do it.
Are you
I'll ask.
Okay.
I can ask. We can look it up.
Yeah. We can probably smoke them both if we need. So, if we look at the degree of the polynomial function, the first one, 2x minus 1, has a degree of 1. The solution, if we solved it, is 1/2. Number of solutions is 1. Our second equation, x squared minus 2 equals 0. The degree is 2 because the biggest exponent is 2. The solutions for this one here are plus or minus the square root of 2. Number of solutions is 2. Our third one is a degree 3. Its solutions are 2 and negative 1 plus or minus I squared of 3. We have a total of 3 solutions. And our last one, x cubed plus x squared minus x minus 1, is a third degree polynomial function, and it has the solutions of negative 1, negative 1, and 1. A total of 3 solutions. Even though negative 1 is repeated twice, they are both solutions. Now this leads us into the fundamental theorem of algebra. If f of x is a polynomial function of degree n, where n is greater than 0, then the equation has at least one solution in the set of complex numbers. Well, we can say 1 plus, if x is equal to 1 as a solution, plus 0i makes it a complex number. So we will have at least one solution to the complex number. But the main part of this is the corollary. If f of x is a polynomial function of degree n, where n is greater than 0, then the equation f of x equals 0 has exactly n solutions, provided each repeated solution twice is counted twice. Each solution repeated 3 times is counted 3 times, and so on. Thus, if we look at this one here, how many solutions does the equation x cubed plus 3x squared plus 16x plus 48 have? How many solutions should this have? It has 3 solutions. Incidentally, those solutions are negative 3, 4i, and negative 4i. But it does have 3 solutions. How many solutions does this one have? 4 zeros, or 4 solutions. We don't have to find them, but if we did, the solutions are negative 2, negative 2, negative 2, and 0. So it has 4 zeros. It has 4 solutions. How many solutions does this one have? So this one here has 4.
Because the degree is 4, so if the degree is 4, it has 4 solutions, which is 4 solutions. So when y
What value of x makes the value of y be 0? How many zeros does this have? Yep. All right. Find all the zeros. So now we need to find them.
Now we're going to do that all left graph.
Now looking at this here, how many solutions or how many zeros should this polynomial function have? 5. So once we find 5 solutions, we know we are done. Now, there's different ways we can go about doing this. The first is we can find all the rational zeros for this here and then try them one at a time. Or we could do what? We can graph it. So we can put it in y equals to graph it first and go from there. Now, with any of this here, we need to find at least 3. Because if we can find 3 solutions, it'll take it from a degree 5 down to a degree 2. Because there will be 5 zeros. But if we can find 3 of them, it'll take it from a degree 5 down to a degree 2. Quadratics, we have ways to solve those. So at minimum, we need 3. But if we can find 4, that's even better. And if we can find all 5, that's the best outcome. So in this here, we'll type our equation in first. We have x to the 5th plus x cubed minus 2x squared minus 12x minus 8. Graph. I think the processing power is a little bit faster. Now we do see that it intersects the x-axis in 2 places. One, at -1, it touches the x-axis and looks like it goes back down. As we've stated already, if it does not cross the x-axis but touch it, there's a good chance there's more than 1 0 at that location. And 2. So -1 and 2. So we have 2. There's a chance one of these might be repeated. So we'll check that here in a minute. But this will at least get the degree down 2, at least with these 2 here. So we can fill our we can use synthetic division to slowly decrease the degree. That'll help us solving it in the end. Now, at this point here, we're going to go through our synthetic division with -1 and then go from there. So we'll do -1 times 1 is -1. 0 plus -1 is -1 times -1. 1 plus 1 is -1 times 2 is -2. -2 plus -2 is -4. -1 times -4 is 4. -12 plus 4 is -8. And lastly, -1 times -8 is 8. And -8 plus 8 is 0. And because the remainder is 0, it is verifying that -1 is indeed a solution. Now we can do this again with 2. And we'll do 2 times 1 is 2. -1 plus 2 is 2 times 1 is 2. 2 times 2 is, or not 2 times 2, 2 plus 2 is 4. 2 times 4 is 8. -4 plus 8 is, and 2 times 4 is 8. And our -8 plus 8 is 0. So the remainder is 0. Yes. So doing more of these is helpful. Paying attention to these is also good. Put those away. Now we do need to find another 0. Now on the graph, we'll look back at the graph. At -1, it touched the x-axis but didn't cross it. So there's a good chance that that point is going to be repeated. So we're going to try -1 again. Because it touched the x-axis but didn't cross it. Because we can look, and I can zoom in a little bit more, so we can say between -2 and 0, we'll go by 0.05. And we see here that the graph doesn't actually cross at that point. We zoom in, you get 1.5, -0.5, we'll go by 0.1. It actually doesn't get above the graph. So let's do zoom 6, fix it. There we go. There's a good chance that it's going to repeat. If it touches it but does not cross it, it's going to be repeated. -1 times 1 is? And 1 plus -1 is? 0. -1 times 0 is? 4 plus 0 is? -1 times 4 is? And 4 plus -4 is? 0. So it means it was repeated. We did have it more than once. Now, we will solve for these. I wouldn't write this step down because, I mean, I could try and see if it repeats again. -1 times 1 is -1. 0 plus -1 is -1. -1 times -1 is 1. 4 plus 1 is 5. Well, that's not a solution because it gives us a remainder of something other than 0. We could try 2. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. And 4 plus 4 is 8. So that's not a solution. And it seems like maybe -2 would work. 1 times -2 is -2. 0 plus -2 is -2. And -2 times -2 is 4. Also gives us 8. But -2 is not listed to begin with, so it's not going to be 1 now. So at this point here, we need to fill the variables back in and solve. So our 0 inside the box is our remainder. Our 4 is our term without x. 0 is our term with x. Weird. So we're left with x squared plus 4 is equal to 0. Now at this point here, we need to solve for the value of x. So x squared is equal to -4. Now since there's not a middle term, we don't have to use the quadratic formula for this here. We can, but it's going to be a little bit easier, a little bit quicker to use the square root method.
Okay, that's what I thought.
Yeah.
Hold on, let me get some formula.
Because it is possible to do this by the quadratic formula, but it's a little bit quicker doing this here. Now that we've got the x squared by itself, we can take the square root of both sides. It would indeed. Because our negative is going to come out as I, and the square root of 4 is 2. So our solutions are x is equal to -1, x2, -1, and plus or minus 2i. Gives us a total of 5. Because we said there should be 5 solutions, and we found 5.
It's plus or minus.
Yep, plus or minus positive and negative 2i. Gives us a total of 5. Questions on this here? Question? Let's look at the next one. X cubed plus 7x squared plus 16x plus 12. And again, with this here, just like the last one, we could start with the rational zeros and then try them one at a time. Or we can plug this whole thing into the calculator. X to the third plus 7x squared plus 16x plus 12. Well, cubed. It'd be helpful if I didn't put the whole thing in an exponent. Since this is a degree 3, we should have how many solutions? 3. Now we need at least 1 to get it down to a quadratic, and we can solve from there. If we can get 2, that's better than 1, and 3 would be the best because we would have all of them. Here we have how many solutions? 2, because we have -3 and -2, because those are 2 values of x that make the y value equal 0. So x is equal to -3, and x is 2. You're good. So we do have 2. We need 3. Hit y equals. Plus. You're missing a plus in front of the 7. So cursor over to the right. So keep going. One more. Plus 7.
Oh, where I typed the whole thing down.
X. Nope.
These are.
Yeah, so the graphing calculators will insert, or the 30xs will sometimes overwrite it as you go.
Okay.
For the most part, the graphing calculator will overwrite it each term as you go, but the powers, it'll leave them there, so it'll move it over. -2. So we found 2, we need 3. There's a good chance one of these might repeat, but let's go on and do the synthetic division. -3 times 1 is -3. 7 plus -3 is 4. -3 times 4 is 16 plus -12 is -3 times 4 is -12. Now at this point here, we do have it as a quadratic and we could solve, but we do have another value of x that we can try, which is -2. Now -2 times 1 is 4 plus -2 is 2. -2 times 2 is -4. And 4 plus -4 is 0. So this is even better than just getting it to a quadratic, because now that it's a linear, our 0 in the box is the remainder, our 2 is our term without x, and 1 is our term with x. Leaving us with x plus 2 is equal to 0. What do we need to do to solve this one here? Yes, we subtract 2 from both sides to get x by itself, telling us x is almost. So our 3 solutions for this one here are -3, -2, and -2. So it does work out that -2 was repeated, and we're able to verify it with this here. Questions on this here? We're ready to look at the next one. X to the 5th minus 3x to the 4th plus 5x cubed minus x squared minus 6x plus 4. How many solutions should this one have? 5, because we have x to the 5th. So here we have 1, 2 for sure, possibly 3, because it looks like one of them does touch the x-axis but does not cross it. And the 2 zeros we have are at -1 and 1. So, okay, we can check to see if it does repeat. So we'll use it twice and see if it works twice. So we'll set up our synthetic division, our constants, our coefficients in the constant term. You want to cross the top? 1 is first. Our 1 times 1 is 1. -3 plus 1 is -2. 1 times -2 is -2. 5 plus -2 is 3. 1 times 3 is -1 plus 3 is 2. 1 times 2 is 2. -2 plus 6, or -6 plus 2 is -4. 1 times -4 is -4, and it does give us 0. Now, because of the graph, it does look like 1 might be a repeated solution, an even multiplicity, so we can try 1 again. Now, our 1 times 1 is 1. -2 plus 1 is -1. 1 times -1 is -1. 3 plus -1 is 2. 1 times 2 is 2 plus 2 is 1 times 4 is, and -4 plus 4 is, so it did indeed work twice. So far we've taken it from a degree of 5 down to a degree 4, from a degree 4 down to a degree 3. We just need to decrease the degree by at least 1 more before we can solve it as a quadratic. So we're going to use -1. Well, -1 times 1 is? -1 plus -1 is? -2. -1 times -2 is?
4.
One more time. -1 times -2, negative times a negative is a positive, and 1 times 2 is 2. 2 plus 2 is?
That's where I was going.
The next one is
What the heck? I messed that stuff up.
-1 times 4 is -4, and 4 plus -4 is 0. Questions on this here?
Did we put the
Variables back in. So 0 is still our remainder. 4 is our term without x. -2 is our term with x. And 1 is our term with x squared.
So we did the quadratic formula.
Yes.
Yes.
Now the values of a, b, and c for this here. A is, b is 2, and c is 4. Because it's going off our ax squared plus bx plus c. Negative b, so -2, plus or minus the square root of -2 squared, or b squared, minus 4 times a, which is 1, times c, which is 4, all over 2 times a, so 2 times 1. Now at this point here, we're going to do some simplifying. Our negative 2 is going to be 2. The denominator 2 times 1 is 2. Now at this point here, we can type everything inside the radical into our 30xs. Well, come on, calculator. So we'll do parentheses, negative 2 squared minus 4 times 1 times 4. Did you put parentheses? Okay. Now, we do need to simplify our radical. The 30xs will not simplify the square root of negative 12 in the form that it is right now, because it can't do negatives. However, our square root of negative 12, well, the negative will come out as I, leaving us with the square root of 12. The yellow calculator will take square root of 12, which is 2 square root of 3. So square root of negative 12 would be 2i square root of 3. Questions on this here before we do the last step? The two numerators are both divisible by our denominator. Two divided by 2 is 2i square root of 3 divided by 2. Well, the 2 divided by 2 is 1, leaving us with I square root of 3. We could split the fraction up, is really what we're doing. Is 2 over 2 plus or minus 2i square root of 3 over 2. Well, 2 divided by 2 is 1. The 2 and the 2i square root of 3 and the 2 on bottom would reduce to 1, leaving us with this here. So our solutions are x is equal to 1, x is equal to negative 1, and x is equal to 1 plus or minus I square root of 3. If we could check, or well, it'd be a little difficult, especially with the I, but that is our solutions here. Questions on any of these so far? Complex conjugate theorem. If a plus bi is a 0 is a solution, a minus bi is also. So what we're saying is if 2 plus I is a solution, 2 minus I has to be a solution. If we have one, we have to have the other. Thus, they always come in pairs. Just like with our radicals, our imaginary terms come in pairs as well. So, let's look at this next problem here. So this here is similar to the ones we finished last lesson with. Polynomial of least degree and a leading coefficient of 1. And we're told that the zeros are 2 and 3 plus I. So we're told the zeros of this polynomial function. We want to work it backwards and find the equation that they go with. Now, we know x is 2, x is 3 plus I, but since x is 3 plus I, x also has to be, guys, let's put those away, 3 minus I as well. Questions on how we set this up? Now at this point here, we need to get each one of these equal to 0. So here we're going to subtract 2 from both sides. Minus x minus 2 is 0. So we have one of the first ones done. Next one, we need to get this one equal to 0. So we had minus 3 from both sides, telling us x minus 3 is equal to I. We did, but this time we're using complex terms instead of, we're using I instead of radicals. Same process, but this time we have i's instead of our square roots. And the last one, we're going to minus 3 from both sides. Then instead of subtracting I this time, we're going to add I. Telling us our last one is x minus 3 plus I is equal to 0. Yep, we're going to multiply it all together. And again, just like with the radicals, we want to multiply our two terms, our complex conjugates, together first. Because you can multiply with the x minus 3 and then with our other term, but it's going to make it a lot bigger. Thank you. X minus 2. Yep. We could multiply the x minus 2 and x minus 3 minus I first, but that's going to make it a lot bigger and a lot more terms to keep track of. So it's going to be better to do, bless you, this multiplication first. X times x would be x squared. Our x times negative 3 is negative 3x. And x times I is plus xi. Now we're going to do the same thing with negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 would be plus 9. And negative 3 times I is negative 3i. And lastly, we're going to multiply through with our negative I. Negative I times x, negative xi. Negative I times negative 3. Negative times a negative is a positive, 3i. And lastly, negative I times I is negative I squared. Now, if we combine like terms, xi, negative xi is 0. Negative 3i plus 3i, 0. Well, I squared, by definition, is negative 1. So really what we have here is minus negative 1. Second I squared. Now our other terms, we have x squared, negative 3x, minus 3x is negative 6x. We have plus 9 minus negative 1. Well, got it out to the side. We have 9 minus negative 1. Negative and negative makes a plus, giving us. Okay. Questions on how we got to this point here? Let me do this one more time. We're going to distribute the x times x squared is x cubed. X times negative 6x is negative 6x squared. And x times 10 is plus 10x. We'll do the same thing with our negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 6 is plus 12x. And negative 2 times 10 is negative 20. And when we combine like terms, x cubed doesn't have any like terms, so it's just going to be x cubed. Negative 6x squared minus 2x squared is negative 8x squared. 10x plus 12x is plus 22x. And lastly, we have our negative 20. And that is our final answer. Questions? No, we'll finish these note sheets due tomorrow. So we'll do one more of these tomorrow. And then we're going to finish this up